Cryptographic methods in cybersecurity. Welcome, everyone. Today, we're diving into a fascinating and essential aspect of cybersecurity: cryptographic methods. Imagine all the data around us, our bank transactions, personal messages, sensitive files, floating in the digital world, protected by one of the oldest forms of security. In fact, cryptography has been used for centuries, from the codes of ancient civilizations to the complex algorithms of today. But in this digital era, it's become a lifeline in protecting our privacy and keeping our information safe from cyber threats. By the end of this video, you'll not only understand what cryptography is, but also how it safeguards your data and the different methods used to keep attackers at bay. If you're as fascinated by the world of digital security as I am, stay with me till the end. Don't forget to like and subscribe for more content on cybersecurity insights and digital defense. What is cryptography? Cryptography is the science of securing information by converting it into unreadable formats, like ciphers and codes, so that only authorized people can decode and access it. It's the first line of defense against cyber attackers and hackers. In the simplest terms, cryptography hides the real meaning of information from anyone who shouldn't see it. This technique has evolved drastically. While early cryptography involved basic substitution and rearrangement of characters, modern cryptography relies on mathematical algorithms that create complex patterns and encrypt data in ways that are almost impossible to break. But why is this so crucial? With cyber threats increasing daily, cryptography acts as the backbone of our cybersecurity systems, ensuring confidentiality, integrity, and authenticity. How does cryptography work? At its core, cryptography relies on two main processes: encryption and decryption. 1. Encryption converts readable data, or plaintext, into a scrambled format called ciphertext. This transformation ensures that anyone intercepting the data cannot understand it. 2. Decryption reverses this process. Only someone with the correct decryption key can convert the ciphertext back to readable data. Let's break down each of these processes in more detail and understand the types of cryptography that make this possible. The key types of cryptography. Now, let's explore some of the main cryptographic methods used today to secure information. By the end, you'll have a clear picture of how these techniques function to protect data in various applications. 1. Symmetric key cryptography. In symmetric key cryptography, both the sender and the receiver use the same key to encrypt and decrypt the message. It's fast and efficient, especially for encrypting large volumes of data. However, there's a catch. Both parties need to securely exchange this key, which can be a risk if not done carefully. Example of symmetric key cryptography. Let's say you're transferring a sensitive document within your company. Using symmetric key cryptography, you encrypt the file with a shared key. As long as the key remains secret, only someone with access to that key can decrypt and read the document. But if the key is exposed, the document could be at risk. 2. Asymmetric key cryptography. Public key cryptography. Asymmetric cryptography is a bit more complex. It uses two different keys, a public key for encryption and a private key for decryption. Here's the beauty of it: the public key can be freely shared, but only the private key can decrypt the message, keeping the data secure. Example of asymmetric key cryptography. Imagine you're sending confidential information to a client. You use their public key to encrypt the data, which only they can decrypt with their private key. This is the principle behind SSL/TLS, which secures websites and online transactions. 3. Hash functions. Hash functions add another layer of security. Instead of encrypting data for secrecy, they verify its integrity. A hash function takes a piece of data and creates a unique, fixed-size hash value. Even a tiny change in the original data will drastically change the hash, making it a powerful tool for detecting tampering. Example of hash functions. When you download software or files, websites often provide a hash value. After downloading, you can check the hash of your file against the original. If they match, the file hasn't been tampered with. If not, you may have a corrupt or malicious version. Now that we've covered the fundamentals, we're just getting into some of the most interesting aspects. Before we jump to the next section, take a second to hit that like button and subscribe for more in-depth cybersecurity breakdowns. Stay tuned as we discuss some advanced cryptographic methods and how they're keeping our digital world safe. Advanced cryptographic techniques. While symmetric and asymmetric cryptography and hash functions are the building blocks, there are some advanced cryptographic methods that are particularly powerful. 4. Digital signatures. Digital signatures confirm the authenticity and integrity of digital messages. When someone signs a message with a digital signature, it acts like a fingerprint that guarantees the information hasn't been tampered with and verifies the sender's identity. Example of digital signatures. Digital signatures are widely used in software distribution to confirm that programs come from verified developers and haven't been modified. 5. Quantum cryptography. With the rise of quantum computing, traditional encryption methods might eventually become vulnerable. Quantum cryptography leverages the principles of quantum mechanics, especially quantum key distribution, QKD, to create theoretically unbreakable security. While still in development, quantum cryptography represents the future of secure data transmission. Example of quantum cryptography. Many financial institutions are investing in quantum cryptography to future-proof their networks against quantum attacks, which are expected to be capable of breaking classical encryption methods. The role of cryptography in cybersecurity today. Cryptography isn't just a theoretical science. It's woven into every part of our digital lives. From securing our bank transactions to protecting private messages and securing passwords, cryptographic methods ensure that our sensitive information stays safe, even in an environment full of cyber threats. E-commerce. Encryption secures payment data when you shop online. Email security. Cryptography protects emails from interception. Social media. Messaging apps use end-to-end encryption to ensure privacy. These are just a few examples of cryptography at work, but the applications are endless. Every click, purchase, and login is shielded by some form of cryptographic protection. Why this matters to you? Data safe. Staying. The next time you log into your online bank, send a private message, or store files on a cloud service, remember that cryptography is working behind the scenes to keep your data safe. Staying informed about how it works and why it's essential empowers us all to use digital technology more safely and confidently. Thanks for watching, and congratulations on enhancing your knowledge about cryptography. Now, you know how crucial these methods are in protecting everything from your private messages to your financial transactions. Remember, your digital security depends on these powerful tools, so stay informed and stay secure. If you found this video insightful, please like, subscribe, and share it with anyone curious about how our data stays safe online. See you next time.